5.3 million. That's roughly how many engineering graduates China produces in a year, depending on how the categories are counted. The United States produces a fraction of that. Yet for decades, Americans were told that the country leading the world in technology would naturally remain the center of innovation. And here's the strange part. Many of the technologies shaping modern life were invented in America. The smartphone revolution, advanced software, the internet economy, cutting-edge chip design. Yet, increasingly, the factories making those products are somewhere else. A country that was once associated with cheap toys and low-cost manufacturing is building advanced semiconductors, launching reusable rockets, dominating electric vehicle supply chains, and constructing industrial infrastructure at a speed that often looks unreal from the outside. Something changed. The easy explanation is that China simply trained more engineers. The easy counter-argument is that engineers alone don't create prosperity. Both statements contain some truth. Neither fully explains what we're watching. Because this story isn't really about engineers, it's about incentives. A student entering university is quietly making a civilization-level decision. Not individually, of course. One student changes nothing. Millions of students moving in the same direction changes almost everything. Imagine two countries. In one, the highest status path increasingly leads toward finance, law, consulting, compliance, administration, and navigating systems that already exist. In the other, enormous national resources are directed toward building factories, power plants, industrial parks, rail networks, semiconductor facilities, robotics programs, and engineering departments. The talent follows the incentives. People rarely move where speeches tell them to go. They move where opportunity pays them to go. That's why the headline comparison between engineers and lawyers is less important than it appears. The real question is what those numbers reveal about the underlying machinery of each society. And once you start looking through that lens, some otherwise confusing events begin to make sense. Why did China become the world's largest electric vehicle producer so quickly? Why has its shipbuilding industry grown to a scale Western countries struggle to match? Why are American policymakers suddenly talking about industrial policy again after spending decades arguing markets would sort everything out? Those aren't separate stories. They're chapters of the same one. A small example illustrates the point. In 2023, while much of the world was focused on sanctions aimed at slowing China's semiconductor progress, engineers at companies such as SMIC kept searching for ways around technical bottlenecks. Progress wasn't smooth. It wasn't magical. It involved thousands of people solving thousands of boring problems. That's usually how major industrial advances happen. History tends to celebrate the breakthrough. Reality is mostly spreadsheets, testing labs, manufacturing tolerances, and exhausted engineers arguing over tiny details that nobody outside the industry will ever hear about. Not very cinematic, extremely important. Meanwhile, America developed a different kind of expertise. It became exceptionally good at creating rules, contracts, litigation frameworks, regulatory structures, compliance systems, and financial mechanisms. Many of those functions are necessary. Modern economies cannot operate without them. But there is a question lurking underneath all of this. What happens when a growing share of a country's smartest people are rewarded for managing complexity rather than building new productive capacity? I'm not claiming the answer is obvious. In fact, this is where the debate gets interesting. Because America still possesses extraordinary strengths: elite universities, world-leading research labs, venture capital networks, global reserve currency advantages, and some of the most innovative companies on Earth. Yet despite all that, manufacturing capacity keeps becoming a national security discussion. That alone should make people pay attention. The deeper issue isn't whether engineers are more valuable than lawyers. The deeper issue is whether advanced economies eventually become so focused on administering systems that they struggle to expand them. And when we look back at the last 20 years, one particular decision set this entire chain of events in motion. Most people know the headline. Very few understand the mechanism. The decision wasn't made in a single meeting. There was no dramatic moment where somebody stood up and announced that America would gradually surrender parts of its industrial base while China accumulated manufacturing capacity. History is usually less theatrical than that. The chain reaction began with thousands of rational decisions made by companies, investors, consumers, and governments over many years. Each choice made sense on its own. Together, they reshaped the global economy. When China joined the World Trade Organization in 2001, Western businesses saw an opportunity that was difficult to ignore. Labor costs were lower, industrial land was cheaper, supply chains were expanding, infrastructure was improving at remarkable speed. A manufacturer looking at the numbers didn't need a geopolitical theory. The spreadsheet already had an opinion. Factories moved. Then suppliers followed the factories. Then suppliers for those suppliers followed them too. What started as a search for lower costs slowly evolved into something much larger. China wasn't merely assembling products anymore. It was building industrial ecosystems. That's an important distinction. A factory can be relocated. An ecosystem is much harder to move. Take high-speed rail. China didn't simply purchase trains. It built engineering expertise, component suppliers, steel production capacity, signaling systems, maintenance networks, and universities feeding talent into the pipeline. Over time, each layer reinforced the next. The result wasn't one successful project. It was a machine that became better at building machines. America followed a different path. Capital increasingly flowed towards sectors with higher short-term returns: software, finance, intellectual property, asset management. Businesses that could scale rapidly without pouring billions into physical infrastructure. Again, none of this was irrational. If an investor can earn higher returns with less risk, that's where money tends to go. Markets aren't patriotic, they're arithmetic. One of the quietly fascinating details from the past 2 decades is how many American executives genuinely believed manufacturing itself had become less important. The assumption was that design, branding, software, and finance would capture most of the value anyway. For a while, that looked correct. Then supply chains started breaking. Suddenly, products that seemed digital turned out to depend on physical reality. Cars needed chips. Data centers needed transformers. Renewable energy projects needed specialized materials. Defense systems required production lines that couldn't be created overnight. The physical world had entered the chat, and it wanted attention. This is where the engineer versus lawyer comparison starts becoming symbolic rather than literal. The issue isn't that lawyers are unimportant. Complex societies require contracts, regulations, property rights, and dispute resolution. Without those things, investment collapses. The issue is balance. A country can survive with too few lawyers for only a short period. A country can survive with too few engineers for a while too. But eventually, one problem becomes visible. Things stop getting built. Remember that question from earlier? What happens when a growing share of elite talent is rewarded for managing systems instead of expanding productive capacity? We're starting to see the answer. Not everywhere, not uniformly, but often enough that policymakers are responding. That's why industrial policy has returned to Washington's vocabulary. That's why semiconductor manufacturing became a national priority. That's why billions of dollars are now being directed toward domestic production under initiatives that would have sounded politically impossible 20 years ago. The irony is almost funny. For decades, many policymakers argued that markets alone would determine optimal outcomes. Then, the outcomes arrived, and suddenly governments everywhere started intervening again. That doesn't mean China got everything right. Far from it. Its property sector accumulated enormous debt. Local governments face financial pressures. Demographic trends are becoming increasingly challenging. Some investments generated far less value than expected. Those weaknesses are real, but they don't erase the industrial capacity built during the process. And that's the detail many discussions miss. Because the most important development may not be China's rise. It may be the realization that advanced economies cannot outsource certain capabilities indefinitely without consequences. Which brings us to the twist. The biggest challenge facing America might not actually be China at all. It might be something happening inside the United States itself. The obvious explanation says America is losing ground because China has more engineers, more factories, and a government willing to think in decades instead of quarters. There's truth in that. But I don't think it's the whole story, because if raw numbers were enough, the outcome would already be decided. And it isn't. America still hosts many of the world's most valuable technology firms. It remains the center of global venture capital. Its universities continue to attract top researchers from nearly every continent. The dollar still sits at the heart of the international financial system. Those are not small advantages. They're the kind of advantages countries spend generations trying to build. Which creates a contradiction. If America possesses so many strengths, why does the conversation increasingly revolve around rebuilding manufacturing, reshoring supply chains, and reducing dependence on foreign production? The answer may have less to do with China's rise than with America's own success. That sounds backward, but hear me out. For decades, the United States became exceptionally efficient at extracting value from innovation, rather than producing every physical product associated with it. Design in California, financing in New York, manufacturing somewhere else. The model worked so well that many people assumed it would work forever. Then reality introduced a complication. National power isn't only about inventing technology, it's also about making it at scale. A country that designs advanced batteries but imports most of them occupies a different position from a country that designs and manufactures them. The same logic applies to semiconductors, industrial machinery, power equipment, pharmaceuticals, and defense components. And this is where the story reverses. Remember the opening comparison between engineers and lawyers? The implication is that China builds while America litigates. It's catchy. It's also incomplete, because some of America's greatest strengths come directly from the institutions that critics often attack. Strong property rights, predictable legal systems, deep capital markets, contract enforcement, transparent accounting standards. Those aren't obstacles to growth. They're part of the reason America became wealthy in the first place. The problem emerges when complexity begins growing faster than capability, when obtaining approval becomes harder than solving the engineering challenge, when building a power line takes longer than designing it, when infrastructure projects spend years moving through procedures before construction crews ever arrive. At that point, institutional strength can slowly transform into institutional drag, not because the rules are bad, because the accumulation of rules starts producing friction. A useful example comes from energy infrastructure. In both the United States and Europe, major projects often face years of regulatory review, legal challenges, environmental assessments, permitting disputes, and local opposition. Some scrutiny is necessary, some protects communities, yet every additional layer adds time, and time compounds. An engineer solves a problem in 6 months. The approval process takes 6 years. That's not a technology issue anymore. It's a systems issue. My own view is that America's challenge isn't a shortage of talent. It remains one of the most talented societies on Earth. The challenge is conversion. How quickly can talent become infrastructure? How quickly can research become production? How quickly can invention become national capacity? Those questions matter more than graduation statistics. And there's another wrinkle. China is entering a period that looks very different from the one that produced its rise. The workforce is aging. Birth rates are falling. Debt burdens are heavier than they were a decade ago. Economic growth is slowing from the extraordinary rates that defined the 2000 seconds and 2010 seconds. In other words, China is no longer the hungry challenger it once was. It's becoming an established power with its own structural problems. That changes the competition. This isn't a race between a rising giant and a declining giant. It's a race between two highly capable systems, each carrying different weaknesses. One risks becoming trapped by demographic and financial pressures. The other risks becoming trapped by complexity. And the winner may simply be the country that fixes its problem first. Which brings us back to that number from the beginning, 5.3 million engineers. The figure matters, but not for the reason most people think. Because the real contest isn't about how many people earn engineering degrees. It's about what a society allows those engineers to do once they graduate. The future probably won't look like either side expects. A lot of people imagine a world where China simply overtakes America and the story ends there. Others assume America's advantages are so deep that no serious challenge exists. Both views feel too neat. History rarely rewards neat predictions. Remember that number from the opening, 5.3 million engineers. The reason it matters isn't because engineers automatically create prosperity. Plenty of countries graduate talented people and still struggle economically. The question is whether those people can turn ideas into productive capacity. Can they build factories? Can they commercialize research? Can they improve logistics, energy systems, transportation networks, and industrial output? Can they create more value than the resources they consume? That's the real test, and it applies to both countries. China's leadership appears to understand this. That's why advanced manufacturing, robotics, electric vehicles, aerospace, and semiconductor development remain national priorities despite economic headwinds. Meanwhile, Washington has quietly changed direction. The debate is no longer whether industrial policy should exist. The debate is how much of it should exist. That alone tells you something important. The argument has moved. My prediction is that the next decade will not be defined by military conflict between America and China. It will be defined by a competition over production. Who can generate more electricity? Who can build more data centers? Who can deploy more industrial robots? Who can manufacture critical technologies at scale? Those questions sound boring compared to aircraft carriers and geopolitical drama. They're also probably more important, because nations ultimately live on what they can produce, not what they can promise, not what they can regulate, not what they can market. Produce. And that's where the engineer versus lawyer comparison becomes less of a statistic and more of a warning. A healthy society needs both builders and rule makers. Engineers without institutions create chaos. Institutions without builders eventually create stagnation. The difficult part is maintaining the balance. Right now, both countries are trying to solve different versions of the same problem: how to remain innovative after becoming successful. China is attempting to avoid slowing down. America is attempting to speed back up. I'm not completely certain which approach wins. What I am certain about is this: the countries that convert talent into real-world capability fastest will shape the next era of economic power. And if future historians look back at this period, they may not remember the speeches, tariffs, or political arguments. They may remember something far less dramatic: millions of young people choosing what to study. If you enjoyed this analysis, subscribe and join us for the next one. There are a lot of big stories unfolding right now, and some of the most important ones don't look important until years later. Sometimes the future announces itself with a breakthrough. Sometimes it shows up carrying a toolbox.